Okay, welcome back to Math Addict 59 YouTube channel. So matrix multiplication is pretty complicated, but there is a pattern. Make sure you understand that matrix A has, I don't have a touchscreen anymore, 2 rows, a top row and a bottom row, and it's got 4 columns. The only way you can multiply this matrix by matrix B is for each of the columns to correspond with the row on B. You're going to create what's called a series of dot products. And pattern's not terribly complicated, but it will take a little practice. And it is one topic out of a whole ton of topics that we're only going to cover in one day. So it's not necessarily a priority for a lot of folks. But so when you want AB, just make sure you understand that because of the 4 columns mixing with the 4 rows, your matrix is going to be 2 by 2. And you're going to get a situation involving row 1, column 1, row 1, column 2 on top. I know it's getting confusing. So top row by the left column, let's call it. So I'm going to do 2 times 2. Sorry about my map. I'm writing with my mouse, and I hate writing with a mouse. But we'll do what we got to do. 3 times 0. 1 times 3. Yeah, see, what's literally happening is if you're in pre-cal and you've heard of vectors and dot products, you're in great shape. Otherwise, it's going to get hard to understand at first. But what you're really doing is you're doing this product. You're finding all 4 of those pairs, you're pairing them up, and then you're creating that product on the bottom. Sound like a plan? Probably not. But we'll continue to work as we can. Now, that's going to lead to, you have to add them up and get an answer. So that's 4 plus 3 plus 12 plus 20. Yeah, 23 and 4. That's going to be 27. Then you have to do row 1 times column 2. And once again, you got to pair all the columns of one with all the rows of another. That's going to lead to 2. Yeah, sorry, it's raining. Correspondences up there. 2 times 1, 3 times 4, 1 times 2, and 4 times 3. Yeah, in fact, just to kind of help you understand, I'm going to erase some of the blue already because there's already too much junk. So make sure you understand that's going to be part 2. And then you have to, once again, do all the products. It looks like a 2, another 2, and 2 12s. So that's a total of 28. Now, this could be a situation where we might have 2 levels of employment and 4 different positions, and maybe you're multiplying by hours. You know, could be a bunch of distance rate times 2. There's all sorts of uses. Now, then you got to do row 2 and column 1, and it's this correspondence. Yeah, things I wasn't thinking about early. So 4 times 2, 2 times 0, which is 0. 1 times 3, and 3 times 5. And that's going to be a total of 15, 8, and 3. 8, 3, and 15. 8 and 3 is 11, and 15 is 26. Oh, nice uniform numbers. They're all looking almost like all each other. So that's what really happened on the part with the red. So we had the part in blue, which was the first row, first column. Then the part in green, which is first row, second column. And then the part in red, which is second row, first column. Then you have one more part. Let's get to the one more part. So it's basically just a tough system to understand. but still, there's uses out there. You might have to group matrices in a real life situation. Now this is row 2, column 2. Just make sure you do that in the right order. That's 4 times 1, 2 times 4, 1 times 2, and 3 times 3. So I'm gonna have to write 4 times 1. Yeah, I'm just gonna put this on YouTube. May. And it's still better than some of the math rules I've seen on Facebook. That's going to lead to 9 and 13 and 9. No, 4, 8. I'm sorry, I have to keep thinking. 4 and 8 is 12, 14, 23. So those are my 4 entries, and my final answer is 27, 28, 26, and 23. That's one example. Thank you for tuning in, and hopefully this helped a little bit.